Moment, can you hear me? Justin, David, Taylor, any of you, can you hear me?
Yes.
Yeah, we
Okay,
can.
hear me. Okay, everyone can hear me now.
Yes, Professor.
Okay. All right, so we're live streaming now. Let's talk about pre-calculus. Okay, so here's our schedule. Today is the 16th. What's due today is the discussion, the logarithmic discussion. Okay, and quiz number, I'm sure quiz number 7. Right? Wish I could see that. Let's say quiz number 7. It's number 7. No, it's quiz number 6. Let's do today. Because this is mod 7. Okay. Any questions on the quiz? Oh, and by the way, look, you have a practice. So just so you know, you have a practice midterm next week. Okay, it's important that you take the practice midterm because it's very similar. No, it's not similar to the midterm. Don't be fooled. People think sometimes there are some teachers that give you a test that looks exactly the same. No, this is not exactly the same. What it is a good idea of the sorts of questions that will come, that you will find on the midterm, but not exactly the same questions. Remember, Alex changes all the questions anyway. So if I give you, this question, it's going to change it. It's going to look completely different. So I just want you to take the practice test like it's a test. The first test wasn't really it was really more about honor lock and your knowledge check. The practice test is more like a test. I want you to take it like a test. I want you to sit down like you were doing honor lock. And I want you to take that practice test. And I need it done before class because I want to go over it. If you can, okay, after doing it after the fact, it's not going to be helpful to you. It needs to be a practice. It's a practice test. It's an opportunity if you practice taking a test without worrying about getting anything wrong, or you get it's graded, but it's graded like a quiz. Okay, but I want you to take it like a test. Okay, the thing about anyone here do distance running, like marathons or anything? No. It's a good analogy. I like it, but you know how many times people who do distance, like run marathons, they run marathons. They don't run marathons every day. They run them occasionally. And when they run them, they treasure them. The midterm is like a marathon. It's like a marathon. An important marathon. Finals, another important marathon. And I just want you to have an opportunity to practice it before you have to take it. Okay? So that's what this is about, and for us to go over it. After that, it's not as important. I mean, it's not going to be as good if I can't figure out what you know and don't know from you getting it done. So try to get that done before next class. Get out of here. All right. So let's talk about the quiz 6. And next week, quiz 7 is due also. And that's the last bit of material that's on the midterm. So you're double dishing here. You're going to do quiz 7, and then you're going to take the practice midterm, and they're both going to have material from 7 on it. In fact, if you look here, remember, again, I'm just going to remind you, one of the helpful things you can do is go down to the bottom of the assignments where it says review test 1, Q1 and Q4. Those are quiz questions 1 to quiz questions 4. But you also have review midterm quiz 5 to quiz 8. I don't think 8's going to be on your midterm. I think 8 is trig, and I don't think we get to trig. So I don't think there's any trig on the midterm, and therefore that you'll know it when you do that practice quiz. You don't have to do it. Okay, so let's look at quiz 6. Oh, the quiz 6 looks really good. How many people did this quiz? Sorry, I have to go back to results. Nine people took this quiz. Okay, not bad. You have any questions on this? Okay, so the thing about what it was that we did last time was we talked about functions. Talked about how you have a function y equals e raised to the x. That's an exponential function. It looks like that. And we talked about inverses. So that's a function. So that function takes, let me add a table to it. Table. That takes -2 and puts it to that number. Okay. So that's a function. It has a domain, a range, everything's wonderful. It has a horizontal asymptote, by the way, at y equals 0. Okay, that's the horizontal asymptote. Let's make it dashed. Okay, then. All right. I told you Desmos will try to graph anything. All those points there are just these points right here. They're the points that make that equation true. So if I switch it around, if I take this thing and I copy it, and let me go down here and I switch the x's and the y's. So I put an x in here and a y in there. See what it did? It switched the x's and the y's. So it actually flips it. But if you go with a line like y equals x, make that dashed green line. Okay, you see that? It flipped it around that line. It's like that line was a mirror. And instead of having y equals 0 as your horizontal asymptote, it's going to have x. It switches the x and the y. So x equals 0 is going to be vertical asymptote. Okay. All right. So we switched all these x's and y's, but now so we don't have a function that looks like that. So let me turn the exponential stuff off. We don't have a function like that. We didn't have a function like that, so we had to invent one. Okay, does anyone remember what that function is? I have x equals e to the y. Okay. That becomes this y equals, anyone? It's log base e of x. Okay. So that green, that's the function we're looking for. Okay. I'll let that go back. So log of x. Now let me see if I can switch these numbers around. If I put this number in, oops, I need a table here. If I put that number in, you see what happens? I got -2. I put this number in. What am I going to get when I put this number in? Tell me. Did I just take it from you? Anyone? Go ahead, Genesis, what? Oops. It was -1. You see how it just went back to the -1. Now I'm gonna take the number 1, and what am I gonna, when I put 1 in there, what am I gonna get?
0.
0. Put this one in. I get, oops, close. It's close to 1. Copy this one. Last one, what am I gonna get when I plug it in here? 2. Okay, so you see what happens? That's what this function does. It reverses the x's and the y's. It's an inverse function. Okay. It has some properties. A lot of properties. Bless you. Okay, it does have a vertical asymptote. Y equals 0. That's the vertical asymptote. Oh, not y equals 0. X equals 0. Sorry. That's the vertical asymptote. Okay. Another thing I can do, by the way, is we don't do log base e. We actually have a name for it. We put a little n there. We call it natural log. That means log base e. Okay. So so ln of x means log base e of x, and log of x means log base 10 x. All right, so let's get to these notes. Oh, sure. I need to look at later on. I'm going to look at the discussion for this, but it should have been very similar to the exponential. I think last time we did both discussions at the same time, exponential and log. It was really just evaluating and solving. That's all it was. All right, let me get my notes. Oh, this are my notes. Check me out. And I'm going to 2.7 down to this way. So we have to talk about evaluating and solving natural log. It's just another function. It's the special function, but it has a different type of asymptote. But let's talk about the properties. Let's talk about the properties. Oh, so some of the things you can do with logs. You know, you could transform you know how you can transform move a function left, right, up, down. Well, you could do the same thing with a log function. So here's a natural log function. What happens if I put a +2 on the outside? What did I do? What happened to my function? Actually, let's do it this way. I'm creating a new function. Where's the old function? Oh, gee. Oh, hold on. There we go. So there's the old function in green, and this is the new function. What did I do? What happened to it? What? Yeah, I raised it up by 2. Did the vertical asymptote change any? No. Okay, what if I put a 2 in front? So let me take this out, put a 2 in front. What does that do? Did the vertical asymptote change any? No, but the function is what we call stretched. It's been pulled up. See, it's higher here and it's actually lower there. It's like if you took if you stretch something like you know that silly putty stuff? Did you ever do that when you stick it on a cartoon? No, you never did because they don't make cartoons anymore. Back in the olden days, they used to have comic strips and you could put the stuff on there and it would pick the ink up and then you could pull it and it would stretch the whole thing. That's what's happening here. It's stretching. Sorry about that. And you can still do it in that way anymore. All right. So what else can we do with it? What happens if I put parentheses here and I put a +3 there? What happens now? What did the function do? Was it raised, lowered, shrunk? So go ahead. Was moved to left. Did the vertical asymptote change? It did change. It changed to here -3. Oh, sorry. There. Oops. It's 2.3. That's the new vertical asymptote. It was here. Now I've moved it there by 3. You know what? That's just what makes this equal to 0. It's one of those skills you're supposed to be able to do when you see something in parentheses like that. You want to know when it equals 0. That's going to give you a vertical asymptote. Okay. Oh, whatever. Okay, those are transformations of functions. Left, right, up, down. You can put a minus sign in front of them. Okay. So there's this word problems here. They're used, we've done those word problems. I'm just going to skip over them. Okay, what about the domain and range of a log function? Because that's I think that was on the homework. The domain for this new function that I've created, this g of x. You see, you can put any number in after -3. You can't plug in -3. So g of -3 is going to be undefined. Okay, but anything bigger than -3, like 2.99999, that's okay. Okay, because it's on this side of that vertical asymptote. What about anything on the other side? Can you give me a number that's on the other side? Negative, what? It's over here. Pick a number.
See?
Okay. One of the things you might be asked is to find the domain. Just take this thing right here. And you say, okay, that has to be strictly greater than 0. You see how it's shaded in all that region? Okay, that's the domain. If it's very complicated, if they put something more complicated in there, just make it greater than 0. Whatever it is. If it's 2x + 3, then that's your domain. Okay. Oh, but 2 in the wrong spot. I was going to say, why did it do it wrong? There it is. All right. Let's keep moving. Main and range. This is review for the composite functions. Okay, so composite functions was that thing we went over last time, putting one function inside another. It looks like you did that because they were on the quiz. These were all quiz questions that you guys didn't seem to have any problems with. So I'm just moving along. All right, let's skip over this because there's videos on all of this. I want to go to the properties of logs. That's what we need to cover today. Lots of pages of review. Just one properties of logs, man. Properties of logs. It's a messy slide. Okay, what is math? Joseph, what is math? It's a language, very good. What is pre-calculus, David? Study up. Study of. Precalculus, the study of what? Study of. It says right there. It's a precalculus. It says something. The answer. That. You can't read that. It's with an F.
F. Functions.
That's it. It's the study of functions. Stephanie. What are the ways we can represent functions? What's your name? Tatiana, it's not, you know, there's this Stephanie looks just like you on my calculator. I'm so sorry. Tatiana. Sorry. You know, I was looking at you, and it's like he doesn't have my name. I'm sorry, I have a really bad headache. I'm doing pretty good, actually. Tatiana, what are the ways we can represent functions? They're listed right there. With numbers next to them. There's AJ. You can answer them. Yes, equations. Words and dot. Okay. And what were the first functions that we did? Do you remember? They're listed right there. Polynomials. Do you remember polynomials? They're going to be on your midterm. And remember things like zeros and end behavior and turning point and faces and passing through or bouncing. Remember all those terms? Those are all properties of polynomials. And I really want you to, I'm hoping that in your life, when you see things, when you see a curve, when somebody shows you a graph of their stock, and it goes like this, woo, 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 you can think to yourself, oh, that's what a polynomial does. I see a polynomial there. Okay, that's what I was hoping you would get from polynomials. Rational functions have vertical asymptotes and horizontal asymptotes. So if you see something that ends the horizontal asymptote, you might think to yourself, maybe a rational function. Honestly, no one sees rational functions very much. I have to teach them, but in my life, I've seen them rarely. Rare. Like, and there's an example in biology that they pull out and dust it off once in a while, but honestly, not so much. Exponential functions are very useful. They have a horizontal asymptote. They either grow or decay, and there were two formulas, the compounding continuously and the compound. Those are really, I don't understand why people forget that the most, but it's probably the most useful part of this course, this exponential functions. Because all your money, when you put money in the bank, it grows exponentially. They give you a growth rate and stuff. Yes, exponential. And if you don't put money in the bank, you know how much money you lose by putting money in a mattress? You'd lose that much money that you could have made by putting the money in the bank. Okay. Does that make sense to you business people at all? Do you know when I went to college, how much it cost me to go to college? Did I tell you this? I know I did. Like, what?
5,000.
Well, I probably lied. Because I don't like to give it away. I borrowed $10,000 from my parents to go to college, and I had saved up $2,000. And I went to Rutgers for 4 years on $12,000, including room and board. Okay. I vaguely remember that a semester was like $500. It was like 4 months was $500. And tuition, I think, was about $500. So, what?
That was still like it.
I know. Well, and I honestly hate the people I went to school with, because they're some of the worst. They're like, kids today need to be responsible. I said, you lazy good for nothing. You paid nothing to go to college. And the reason why you paid nothing is because the government paid. There was all types of we didn't have scholarships. You had scholarships. I got a scholarship. It was like $200. Woohoo! That was a scholarship that my high school gave me, but it wasn't meant to pay for college. The government paid for college. And all these, and then you know what all my classmates did? They left college and they majored in something else.
least I majored in math. So, okay. But these people left, got jobs easily. So they paid nothing to go to school. They got jobs easily, and now they're giving you a hard time and racking up your debt. But I'm just telling you, my whole point is that money grew exponentially, and it grew only by 5 or 6%. Like tuition's only grown like 5 or 6%. And now you pay a lot more than I do. Okay. And when you get a job, I had a friend in college, he took a year off and paid for 4 years of college with his summer job, not summer job, he took a gap year. Okay. And he paid for his 4 years of college with what he earned in a gap year. You cannot make $200,000 in a gap year. Okay. He was working at a factory. That's how cheap it was. So it was cheap then. Colleges were cheap. So if you put your money away and you don't spend it, you lose it exponentially, and it's a lot. It doesn't seem like a lot. I mean, if you consider credit cards, you guys have credit card debt, any of you? How much? 17%? Is it 17? What do you pay in?
I'm on like student accounts, I only get 1% cashback.
Oh, good. No. How much does it cost you if you don't? How much do they charge you interest?
They charge me a student account.
Well, get yourself a real credit card that charges you 17% interest, and then see how much. They're so innocent about it too. They're like, oh, just make this minimum payment.
Yeah.
Just minimum, so much.
It's not even like minimum payment, just whatever I spend is what it's just that's all I have.
Well,
But I don't pay anything on interest.
no, but regular credit cards will suck the life out of you. At 17%. It's highway robbery.
But it's-
Okay.
Like the benefits are better, right?
The what?
Like the benefits are better, like the cashback is what, 3%?
You've got to stop thinking that way. People are telling me, so like they're telling me that I should borrow money so that my credit rating will go up. And I'm like, I'm not paying that. That's a fee to make my credit rating go up. My credit rating is fine without me having to pay them money. But they're like, oh, but if you borrow money, they'll love you and they'll raise your credit rating. I'm like, no, I'll keep the money, thank you. But yes, you know this thing? They're like, oh, you should leave some balance on your credit card. I do not buy that 1 second. I never leave any money on a credit card, ever. And my credit rating is just fine. But they want you to do that so that they can con you into losing money to them. It's just a fee. They're just taking your money. All right, but exponential is good. Now logarithms. So logarithms have properties. The first thing you need to know about logarithms is that they are an inverse of exponential functions. They are used, they were invented as an inverse. So look, an exponential function, if you look at this slide, the exponential function has the green horizontal asymptote. The log has the vertical asymptote. The exponential function has a domain of everything. Well, the log function has a range of everything. This goes, you can't see this graph that well. Let me go back to the Desmos thing. Oops. This logarithm function, that goes all the way down. You can't see it, but I promise you that it goes. So if I go on this and I keep clicking, it will go all, it says 0 is undefined. My graph can't get close enough to see that it actually goes all the way down. Goes to minus infinity. Okay, because it came from an exponential function. Exponential functions, let me just go back to the exponential function. This guy goes all the way to the left. So when you flip it, that green line goes all the way down. But it's creeping closer and closer and closer. It can't, in a way, it can't be on top of itself. It can't be a vertical line because then it would fail the vertical line test. It just has to get closer and closer and closer and closer, which it does. Okay. If I zoom in here, if I zoom in on this line, you'll see that it's not a straight, it's never a vertical line. Okay. I'm just getting closer and closer, but it's still looking like that. And it goes all the way down. All right. So that's one of the properties of, oops, sorry. All right. So there's 5 properties of logs. Okay. There's there's lots of properties, but these are the ones that I call, and I sometimes just abbreviate them by property one, the definition. Okay, so this is how logs got invented. So the first thing to know is that, let me go here, I'm just gonna make the notes, I don't make new notes. Just because I feel like it. It's out ahead. And the screen is too big. Okay, so what I don't want that. What did I just have? Okay, so here's what I got. I created it this way. So I had y equals a to the x. To find an inverse, I need first to solve for the x. So that's the first property. So we'll call it property one. Property one. And that says this, if let me do it this way. If y equals b to the x, doesn't have to be any base. Okay. Then x equals log base b of y. Okay. So if I'm trying to solve for an exponent, if I have something, for example, if I have 10 equals 3 raised to the x, then, then what? By the definition, so then I say then by property one, I want to solve for the exponent. To solve for the exponent. Oh, let me write that down. You hear the word solve for the exponent. Okay. I can use that property and tell me, so there's the x. So that's what I'm looking for. So by property one, I can say x equals. I know it's a log. What base? Okay, there is a base. What's the base? Is the 10 the base or the 3 the base? The base has an exponent. The exponent is the x, right? So what it does have to be? Log base. What? 3 or 10? 3. And then what's left over? 10. Okay. So let me just say that. So if I have x equals log base 3 of 10, let me just say I can get Desmos to tell me what that number is. Nobody knows what, I mean, unless it's super easy. That's 2.09. So 3 squared would be like 9, right? So this is a little bit more than squared because, does everyone get that? So that's what it allows me to solve for an exponent. So if you ever hear me say, I need to solve for the exponent, I'm using property one, I'm using the definition. Okay. There's, for every forward, there's a reverse. So this one is the forward. The reverse would be this. The reverse is to get rid of a log. Okay, so if you ever hear me say, I want to get rid of a log, then I'm going to use the definition. Okay, so let's make a formula with it. Let's put something with a log in it that has an x. So log of x plus 1 equals, 3. Okay, we'll make it log base. Okay, I want to get rid of that log. Okay, there's the words get rid of the log, so I'm going to use the definition. Okay, when you hear me say this, this is log base 2. What do you know about this information here? Log base 2. What is 2 then? 2 would be the what? The base. Yes. 2 is the base, and I'm going to raise it to a power. What's that power going to be? Okay, I have 2 choices here. I have x plus 1 or 3. Which is it going to be? If I wanted to raise the 2 to the x plus 1, I wouldn't need anything. It's right there. The 2, the x plus 1 is right next to the 2. I would just be, why'd even write the word log? It's not the x plus 1. Okay? So if it's not the x plus 1, then what is it? 3. And that equals what's left over. What's left over? X plus 1. Okay, and I can solve that, right? 2 cubed is 8, minus 1 is 7. Right? So this is 8 equals x plus 1. I subtract 1 from both sides, and I end up with 7. Okay, I could also, because Desmos is so awesome and powerful, I could literally just type this, and it just gives me the answer. 7. Okay, but now you know you have this property that allows, the definition is a property, and it can be used to either solve for an exponent or get rid of a log. Okay? Any questions on that? Let's try another. That's property 1. Definition. It's a good property. I'll send this to you if you want. Just to remind me not to screw it up. Okay. Let's do property 2. I know I've done these before. I know I have something where there are folders and everything, but I'm just going to do it this way. Property 2. This is what I call the sum product property. Oh, no. Sorry, property 2. See, I'm getting weird. I gotta do it this way, sorry. Okay, so because we're solving for exponents, the log isn't solving for exponents. Do you remember what happens when you take something like x? So x is our base, and you square it, and then you take x to the 3rd. Do you remember what happens? What happens to these? So I have the same base, right? It's x. That's x to what power? What do you do to those exponents? You add them. Oops. Forget that. But this is something we remember from algebra. If we multiply things together, the exponents add. Okay? So the sum product property says this. It says if you have a log of any base, so I'll just speak of a, I'll call it M.
plus the log base b of n. So I have two logs. I can combine them and make it the log base b of mn, if they're multiplied together. Okay, in other words, if I'm talking about, if I want the b raised to what power is m times n, well, it would be the same as b. I'm just adding these exponents. Log is solving for exponents, and since I'm multiplying things together, I would be adding their exponents. That's the sum product property. So the first thing it can be used to do is the word you want to hear is, you want to hear something, combine logs. If you're ever asked to combine logs, and let's call that the forward. Okay. So if you have, for example, the log base 2 of 3 plus the log base 2 of 10. Desmos has already told you the answer. It's 4.90, but it's also equal to the log base 2. Let me write it this way in the next line, since Desmos said it's the log base 2 of what? What's 3 times 10? 30. I'll write it this way. See, same answer. Okay. So if you have a bunch of logs and you want to combine them, this is your property. Okay. If this was an X, there would be a graph, and then this would be an X. It would be the same graph. Okay. Combining logs. The reverse. The reverse is weird. The reverse is if you want to break apart logs. Okay. So here's something. Do you know what the log is? So let's say we don't know what the log of 2 is. There's the answer. It's 0.3 something, something. I don't have to show you use a log table, but back in my day, we had a thing called the log table. You will never need that. Let's talk about the log of 20. What's the difference between those two numbers? Look at them. So, oh, I should tell you what this base is. Okay, I need to do something first. Can I just tell you what the log of 10 is? When I write log base, that means base 10. Log base 10 of 10 is 1. Okay. 10 raised to what power gives you 10? 1. You could use the definition for that. Okay. All right. Log of 2 is equal to that 0.3, but log of 20 is the same as log of 10 plus log of 2. Okay, that's what log of 20 is. Log of 10 plus log of 2. In other words, I broke 20 into 10 and 2 because I know that the log base 10 of 10 is 1. What's the log base 10 of 100? It says it right there. It's 2. What's there? 100,000 is 5. If I have 200,000, I can break it apart and I can make it 100,000 plus 2. Okay. So I know what log base 2 is, right? It's this thing. What's the log? What did we say this was 5? So I can just add a 5 to it. Okay, and I get 5.7. All right. I want to break us up into our groups right now, because I think this is too many properties to do at once, and the next property is a really good one. So I'm going to stop, I'll pause, and I'm going to put you in your groups so that you can get ready to present them. Okay? Let's break up into our groups.
What are we presenting?
What you did last time, make sure it's done. And then you can start working on the next one too. Okay. How many groups do we have in this class? 5? Okay. Well, let's do it. Okay? All right, I'll be right back.
This week? Oh. You're gonna do next week, you're gonna do. And then with 7, right? Classes are okay. What are you doing? No. Because this, I'm trying to put my books into one. Books, it's too many at once, and it's like, I know I'm doing better in classes than some. It sucks, because I'm like, the class I. Yeah, because this one I feel like I'm winning more, where it's not really well. But then my other classes, I'm like, oh, that's so good. And it's just this one. This one and something else. I know you like to. With 3 classes too, and you working. Yes. I definitely feel that. How many classes are? You want to get 2 classes? What then? You're like,
I used to 4 this semester right now.
oh, you were like,
I mean, I have a full-time job. He's working hard.
oh, yeah. What are you ready for?
Working. There's a job that is called multiplying time. I'm just waiting to start some classes for I use get you the job. That's
Cool.
it's fun.
It sounds fun.
It's too much time for that.
Yeah.
You don't have any discussion.
You don't have any classes. Okay, wait, did we study? Okay. That's what I'm.
Okay. Dennis. Where are you? Taylor, Michael, Justin, do you guys remember what room you're in?
You put me on group 3 last week, I think.
AJ's waiting for you. Join room 3. Who else is in your group, AJ?
I don't know the names.
Jake,
She.
James, Justin, Taylor? No? Okay, let's take a look at.
I just texted them. Join the.
I'm in AJ's group.
Then you're in room 3, James.
All right.
Octavio. What group are you in? You're in 2? Are you in 2? A moment is waiting for you in 2. He's in your group? Well, he's in your group.
Can you guys hear?
I'm just trying to find Justin. Michael C. Michael C was in your group too. Michael, are you there? Michael C? That's Michael Charles. Michael, hello. Justin.
Yeah,
Justin, what's your major, Justin?
computer science.
Where's my computer science group? Then you're in room 2.
Okay. I'm changing right now.
Michael C. What's your major? Uh-oh. Jake moved into room. Jake's in room 1 all by himself.
Sir, what group am I in?
Mr. Porter, what group do I do?
I'm sorry, Jake, you want to go to room 1, but I don't see anyone. Isn't that where room 1 is? But don't. Oh, you're room 1. Oh, is he in your group?
Yeah.
Jake?
Yes.
All of your group 1 is here, but they're not joining. Come on.
They're not okay.
Yeah, no, somebody's gonna do it. I think.
Yeah.
Now I can't get Stephanie out of my name. The T. Tatiana. Tot's gonna join.
Oh.
You all got your, every one of them has a computer. Nobody wants to join Zoom. Come on, Joseph, David. Do it. Alexis. Are you on? Are you talking to Agent?
Oh, yeah, I'm on.
Okay. You guys aren't talking though. She's not talking.
I'm just, we already figured out who's talking,
Oh, okay.
who's presenting.
Good. Okay, so I've got AJ, Genesis, and Moment. So I only have 3 groups. So David, oh, David's you're joining. Michael C. I don't know where Michael C goes, but he's not answering me. Michael C. His name is Michael Charles. All right, well, whatever. He can join any group. I don't care. Somebody leave him something to do. Okay, so AJ, this was yours.
Yeah.
I see a bunch of evaluates and a solve. We're good. So now just get somebody to reply to you.
Going in pod?
Nobody has replied to you, Alexis. This is for the log regression. You did it?
Scroll down.
I don't see any. Oh, maybe hold on. Maybe I clicked in. Oh, yeah, there we go. Alexis did. Sorry, Alexis. And Akash did too. Okay.
No,
Anyone else in your group? So what I have here, I'm not thrilled about this though. These are 2 writers and neither of them put units in. Okay, somebody's got to do some words. They're gonna have to say what it means. And these are both, okay, and there are 2 different evaluates and 2 different solves. But how are there 2 different solves from that one post? 215 is 7474. That's the only solve. 215, 7474. So 215, 74. So Akash has the right solve. You should remove this because I don't know what that is.
Do I need to remove something?
No, I need.
No, and he needs to remove this. What's that? That crap. Let me see this again. Hold on. You were trying to find out how tall a person who is 215 is. Okay, so you put in 215 as this horizontal line, right? And then you found 74. So that's a solve. You put 215 goes back to 74. I don't want those decimal places there. He should just have 215. You did this other one that was an evaluate. You did it as a solve. You said, if I want to know somebody who's 217.58 pounds, nobody cares about 217.58 pounds. When I was that, I didn't care. Like 217, you have to pick no, if you're solving for something, you're not solving for something that precise. Do you know what I'm saying? This isn't just an evaluate. 75 goes to, this is just an evaluate, but you guys don't have to do, you can split them up if you want. Split them up between evaluate and solves, but somebody has to say it in words. You have to talk about it. Don't just leave, and there have to be units like pounds or inches. Okay, you have the backbone of what you need to say, but you don't have pounds and inches in it. And someone's got to actually say it in words. According to which regression you're using, logarithmic regression, a person who's 70 inches tall should weigh 181 pounds. That's how you would say it. So someone in your group has to say that. Is anyone else in your group besides Alexis and Akash?
Yeah, they're all in.
Oh, well, leave Akash, even though his thing is wrong. He'll have to fix it. If he doesn't fix it, then he's going to lose some points. But I would, if you don't have enough people, then Alexis can change hers. Otherwise, just you have 2 evaluates and 2 solves. But Alexis, that solve is not great. But his isn't good either. So, okay, because in the solve, this number should be a solid number and that number should be messed up. Okay, just like this is an easy number to a messed up number, this should be this should be giving you the answer should be an easy number to a messed up number. All right. Okay, so that's your group. You guys are height and weight. Who are the people at home? Taylor, James, those are all people in your group? Yes?
Yeah, I just sent them a message to 2 evaluates, 2 solves, and threaded words.
Okay. All right, Octavio and Justin a moment online, but you're there with them. So which did you guys do one last time? No, but they posted this moment posted one. Okay, so let's see if he has an evaluating solve for you. I see a horizontal line, so, but he didn't post it. Moment. Do you see that horizontal line? Let's see if he gave it, if he's nice, he gave us a link. He didn't give us a link either. So now we have to dig. Where is that horizontal line? Okay, it looks like it's at 5. Do you see where I'm looking at 5? You see that horizontal line there? Do you see this horizontal line? I can see that that's the number 2, that's the number 4, this must be 5. And looking at these numbers, it sure looks like 5. So I need to know this right here. It looks like 20, a little 22 point something. But he didn't even bother finding it. Shame. Moment, find it. I need this point right here. I need the solve. I need the. See that intersection right here? That's going to be somewhere around here, 23 point something. So you can see that right, if you had a number like 23 point something would be actually, oh, it looks like it's 22 point something. Because it's already at 5 at 23. So it's 22 point something. Okay, so you need to find that so you can do your solve. Okay. All right, tell him to do that. Since he's there, he can fix it. Okay, let's see the next one. Oh, did anyone answer him? Nobody answered him because you couldn't answer him only with an evaluate, couldn't do a solve. Okay, how about the next? This is your group, Genesis. Oh, and look at you, you gave me a link. I like your group already. And there's a horizontal line, and look, you gave me the 20 and you put it in there. So these are all of, you have 2 evaluates, and I don't know what that is. Is that a solve? 23.01? Because it's not solving anything easy. See what I'm saying? It could just be sitting there. I don't care. I see evaluates and solves. You just put maybe 2301 was your birthday. Who knows? You're born in January. Yeah. Okay, so maybe it's January of last year. All right. So you have all the things you guys need. So now all you have to do is reply to it. Let's see what people wrote. Tatiana wrote N of 11. I don't know. So I see David has H of X equals 11. So David, you wanted to know when there were going to be 11 million people. And then you said that happens in 2026. That's a solve for sure. Tatiana, I think you want to evaluate. But if you evaluate, the population depends on the year. So it's going to be a year in here. And then you'll have an answer that has more decimal places. Okay? Joseph says, according, where is Joseph? Did he leave? According to the, okay, this is a natural log regression. Let me just go back. Everyone should know this. Maybe not, because I didn't cover it that well. See, there's an ln in there. That's natural log. So and it says right there, natural log regression. So make sure your speaker says natural, according to the natural log regression. Where did it go? Okay, and look, Tatiana, look, you just can say what the population is in 2021, or look, 2025 is even better. Just say N of 2025 equals 10.4333 million people. Okay. All right, so let's see. I'm down to Joseph. In 2027, according to the natural log regression, in 2027, there will be 11 million people. I think he's trying to reply to yours, Tatiana, and yours is not great. So he really needs to say, according to the regression, no.
I think you should do 2025. He should say, according to the natural log regression in the year 2025, there will be a population of whatever that number is, 10 point something something. Okay. Do you have anyone else in your group that needs a job? David. No, David to solve. Tatiana did evaluate. Joseph's is putting them in words. That's who's missing. You have somebody at home? Who?
Jake.
Jake. Okay, so Jake can say. He can say that since Joseph is doing evaluate, Jake can reply to David and say, if we, according to the natural log regression, if we want 11 million people, that'll happen in 2026, the middle of 2026. Okay, good. Everybody on their way to solving this so we can move on. Here it is. Still don't know who Michael C is. He's not replying to me. Michael C. Who I have to take attendance. Let me just do that.
Professor.
Who's talking?
Michael Tavares.
Michael T. Yes. What group are you?
What group am I in? Just asking.
You're all alone in room 4,
Yeah.
but there's nobody in there.
Yeah.
I don't remember. Was there other people in your group? Was Michael C in your group?
Nah. I forgot, to be honest.
I could look it up, but why don't you just join one of the other groups?
That would be better. I'm not gonna lie.
Who has extra jobs? There's lots of things to do. You could always do another evaluate anyway. All of you have lots of evaluates. But the other thing you could do is have a presenter who says something. Whose group is good? How about Octavio? You want to take him in your group? His group is gone. Okay, and you're going to take Michael too, I think, because you got the smallest group. Okay, so join room 2.
All right, thank you. Which discussion are we working on today? I'm sorry.
The natural log.
All right.
The exponential was due last week. But today we're working on natural log. I didn't look at the exponential one. Okay. The hell am I doing? Okay. I was leaving for some reason. To take attendance. Attendance. How do I do that? Yeah. Okay. Attendance. Who do I have? Justin. Is he here? He's here. Joseph. Here. Michael. Michael, should I mark him present when he doesn't answer me at all? Think about it. Sebastian. I haven't seen Sebastian in a while. Isn't he in your group, AJ?
Who?
Is Sebastian in your group? Oh, that's you. Oh. I'm gonna blame it on my headache. I'm not watching the video. Emiliano. How about him? He's not here. Taylor is here. Taylor. Do you see a Taylor on this list? Yes. Octavio is here. Tatiana is absent. Instead, there's Stephanie. Oh, Jake is here. Christopher. I haven't seen him in a while. David's here. Genesis is here. Akash is absent. Dennis is here. Jimmy is absent. Alexis is here, Moment's here, AJ's here, Japnor is absent. Michael T is here. So. Oh, did we decide yet if we were gonna give Michael C an absent? I'm gonna give him a late. Because he's still not answering me. Ah. So. Okay, so AJ. This was, you did, this was exponential. Are you missing something here?
I don't think so. Am I?
We're missing the solve. You have this line for 215 pounds, but how tall should you be?
Oh, so I need to add a.
You need to find out where this is. Should be around 70 something inches, and there should be like in that spot. There should be a long number instead. These are all evaluates for different heights. You
I need
need,
to add that line that intersects.
yeah, find the intersection and do it. Okay. Did anyone reply to you? This is last week's. This one's already done. Oh, Alexis did say. Okay, Alexis, what are you trying to do here? Akash is just writing a fancy evaluate. He's saying when x5 equals 80, E of x5 equals to. So if somebody's 80 inches tall, they weigh 243 pounds. Okay. All right, these are okay. The only one I want to see here is Dennis. According to the graph, again, don't just say according to the graph. I want to know what the regression is. This is exponential. This was last week. That should say, according to the exponential regression, at a height of 75 inches, the weight doesn't increase to, it is. If you're 75 inches tall, you should be 212 pounds. Okay? So that sounds like an evaluate. Justin's, I don't know what these people are doing here. Taylor, these are weird. Okay? I'm not sure what you're doing. Alexis doesn't need to do two, but I see what Alexis looks like an evaluate. It looks like this looks like an evaluate. You say E of 20. Somebody who's 20 inches tall weighs 47 pounds. Is that what it says? Do you know somebody who's 20 inches tall?
Babies.
Baby. 47-pound baby. Toddler maybe. Okay, but this right here, that should be an, I think that you're trying to say E of 75 is 212 pounds. So these are both evaluates, but you're saying that you're trying to say this like it's a solve, but it isn't. Okay. Well, if I want somebody to be 212 pounds, then they would be 75 inches, but nobody wants 212.10752 pounds. Do you know what I'm saying? Okay. And this is just Akash is just a fancy evaluate. Taylor. Okay, Taylor just rewrote what you wrote. So, no, so, and you both wrote them on the same day, but since yours is posted first, he won't get any points for it. So Taylor, you gotta do something else. Justin just did, sorry, just.
Thanks for exponential.
Justin threw E of X5 equals 243, but he didn't tell me, right, this was last week's one. Doesn't tell me what X5 is. I don't know what you're trying to tell me there, but it should be, if you're doing an evaluate, there's no X in it. If I, like that one right there, E of 20, that's a specific evaluate. A baby that's 20 inches tall, 20 inches long should weigh 47 pounds. Okay. All right, that's your group, AJ. Fix that. Genesis. Genesis gave me a link. So I see that in 2021, there's going to be 9 million people. That's a nice evaluate touchdown. You see how nice it did that? I buy it. David. That's a nice solve. You see how you wrote the exponential has to be 11 million. That happens in 2026. I like it. Joseph, according to the exponential regression, just according to the exponential regression, in 2021, there will be 9.2 million people. Don't mix math notations. Just say it in words, like you're talking to your mother. How many people will there be in 2021? Well, Mom, according to the exponential regression, in 2021, there will be 9.2 million people. Does that sound like you would say that to your mother, maybe? Would you understand that? And Momin did another evaluate. Is Momin in your group? He just tapped onto you because the other group wasn't there last time. But he can do that. In 2024, there are 10.1 million people. All right, fine. Whatever. Did I get to your, just one last group? Michael. According to the graph, when the year is 2020, gas prices are $2.95. So according to the regression, don't say the graph, say the regression. And nobody should do every job, Michael, so you didn't even have to do that. You did this, except you didn't do this correctly. He can't hear me. He's in a room. He's in room 2. Do you see why this is wrong? He did a whole lot of evaluates, but he didn't do a single solve. Yeah, that's what.
Does that make sense? I fixed that. That look great.
Okay, click on the intersection. That's
Oh, it's not this one.
no. Oh, that's at 75.49. So copy that. Paste it in your team.
Okay, gotcha.
Good. See what's wrong here? He has all these evaluates from all these years, but not a single solve. So, no. Are you guys doing the gas prices? What's your topic? Drugs? Sales? What are you trying to sell? 6 billion. $6 billion what? Newspapers? Oh, I don't remember that topic. You guys are best friends, BFFs? And you guys are, wait, aren't you BFFs? Where's the BFF people? Oh, they're probably the group that's missing. Gas prices and BFFs. But you're neither of those, so you're something else. Okay. Well, doesn't matter to me. Just make sure you say it correctly. The whole point is to know how to say it.
Okay. I'm gonna go back soon, so finish up what you're doing. Okay. We're gonna end this because I got a lot to do. All right. Are we back? Gonna get started again? Back on these properties, so that last property hardly has ever used. It's used for tables and stuff, but you don't really need to break apart. You're never gonna have to break apart logs. You might have to combine logs, but you're never gonna. But one of the things that you could think about with logs is if you have an earthquake that's at like 5.3 on the Richter scale or whatever versus 0.3, it's actually 100,000 times worse. So that number 5 is 100,000 times worse. Okay, so what's the ladder property? So the ladder property is says this. If you have something like y equals a log base b of c, then y equals log base b log base b of c based to the a. Okay, so all that happens here, this is a property that's used quite a bit. See that a in the front? It could be moved up. I call this the ladder property. Let me draw a ladder for you. Because I can draw my straight ladder. Because it's like this. Imagine that there's a ladder here. Loop, loop, loop. You know what a ladder is? You still have them, right?
Okay, so a ladder can be used to go up. So we can go up the ladder. So this moves the A up here, or then we can go down the ladder. So forward or reverse. Forward means we can go up, and the reverse means we can come down. Okay. Let's see if I can, I'll just write that forward. Is up. And the reverse. Down. You don't have to remember forward or reverse. I'm just. So for example, if we have something like 2 log the x plus 3 log y. Okay. What we can do is by property 3. We can change that to log of x squared plus the log of y cubed. Now we can use property, the one where you can combine logs, that would be property 2. By property 2, you can write it as the log of x squared y cubed. Okay, so property 3 forward, I can move those up. I can take the 2 up, I can take the 3 up. And then property 2 says I can combine them. If I'm adding logs, I can combine them up. Okay. So let me give you an example of the reverse down. I know that the log of 10 is equal to 1, right? So if I have 10 raised to the 9th power, I can bring that down, and then that just becomes 9 times 1. Does everyone see that? Or 9 times the log of 10. Okay, so I brought the 9 down. If you need to bring an exponent down, you would use this property. So you can either bring it down or you can move it up. Okay, change of base. Change of base says this. If you have any log base b of a, you can introduce a new log. Then you could do this. You can say that that's equal to, say y is this. We say then y equals, it's a fraction. It's going to be the log of a over the log of b. But it can be any base you want. Put a little c in there. Okay? It has to be the same base. So for example, log base 2 of 3 is the same as the log of 3 divided by the log of 2. You see how they're the same numbers? Also, another ln of 3 divided by ln of 2. One of the reasons I like to change it base, I liked ln because it was less writing. Okay, but you could use any base you want. And it's true, the change of base just means that if you could change any base. If you have log base 2 and you want log base 10, then it's this. If you have log base 2, you want natural log or base e, it's that. That's the forward. So the forward of this is to change base. The reverse of this is a silly thing.
is just to divide logs. So if you have something like log base 3 of 7 divided by the log base, they have to be the same base 3 of 14. That's the same as the log base 14 of 7. Okay. And don't be thinking that that's like a half or 2. That people make that mistake. But if you have the power of decimals at your disposal, I'll watch this. There, it's not. Just because things look like they do something logs exponents, they don't always double check. Okay. The last property is called the log of both sides. And I almost don't even waste time on it. But you know when you have something like x equals 4, you can square both sides, and you could get x squared equals 16. You could do the same thing to both sides. You can square both sides. You can take the square root of both sides. You can add to both sides. So you can take the log of both sides. If you have something like, so here's what it says, if y equals m, then the log base b of y equals the log base b of m. Okay, so you can take the log of both sides. The forward is if you want to take the log of both sides, you could just do it. Okay, the reverse is I'm just going to do the reverse, is that you can drop logs from both sides. So an example of that is if you have the log of x equals the log of 7, you can just drop the word log. So then you would say, by property 5, x equals 7. Do not divide both sides by the word log. The word log is a function. It's like the square root or squaring. You don't just write it. That doesn't just happen. All right, more properties. Inverse properties. So remember I told you that if you have something like this, f composed with g of x, remember this? And if they were inverses of each other, they just give you back what you start with. You saw this on the quiz last time. Okay, well, since log and exponent, so since these are inverses of each other, exponential functions. So if you take b to the x is inverse to log base b of x. So that means I can do this. I can plug them inside of each other, right? So b raised to the log base b of x is just x. Okay? And the other one, the log base b of b raised to the x is also just x. So an example of this would be the log base 10 of 10 of 100 or 10 squared is just 2. Okay? 10 raised to what power is 10 squared? It's 2. Okay? You don't see the other ones so much, but I will show you something though. Here's another example of the other one. If you have something like 2 raised to the 5 log base 2 of 3. It's 243. But let me ask you a question. How can I find this? Well, you see that 5 in front? It can't be there. I have to get rid of the coefficient. Remember that ladder property? I'm going to get rid of that, and I'm going to move it up. I'm going to say that equals, and take that 5 and move it up here. So it's 3 raised to the 5th power. Okay. Now, because the log base, since these are inverses of each other, I can just cancel them out and I get 3 raised to the 5th power. And what's 3 to the 5th power? 243, right? Okay. They were just interesting properties. Okay, so now let's go to the Alex thing. There's one more property that I didn't show you. Remember the sum product property? So I never do this property, but I'm going to tell it to you right now. The sum product property was property 2. There's another version of this. I'm just going to, copy this and I'm going to paste it. There's another version that I'm going to put right here. And if there's a minus sign there, then this is division. Okay. And m divided by n. And I'm just telling you that because that you could prove this. You don't have to prove it. You could just use the other properties to get this. But this is on Alex. So let me just go on Alex and start looking. So the first question is just the basic properties question. This shows up on a lot of tests because it's just what I just went over, those 5 properties. So what do you do if you have the log base 3 of 4 plus the log base 3 of 7? Okay, I want to combine it into a single log. Do you remember which property we used when we went to combine logs? Which property was that? Okay, since it's new in your head, it was property 2. And then what you did was when you're adding the exponents, you're multiplying what's inside the argument. So what do? You multiply 4 times 7 and you get what? What's 4 times 7? 28. Okay, so that's what you do, just multiply them together. All right, now the one I just showed you was that other property. If you have the log base 9 of something minus log base 9 of 5, and you get log base 9 of 4 over 5, what was in there? 4. Okay. Now this is the hard one. This is the latter that property. Except I have what power? So there's nothing in front of the log, but now there is something in front of the log. 1/16 is the same as 2 raised to what power? Okay. 1/16. I have log base 2 of 1/16 equals 16. Equals the log. And is it base 2? It might not be base 2. Let me see. Let me move it over. It was base 5. That's what I thought. It's base 5. So I'm just copying the problem down. So this is log base 5. And then it was something. We don't know what that is. Let's call it x. X log of 2. Okay. So one of the things we can do is just algebra. We can take this 16, that is 2 raised to the negative 4. Right? 2 squared is 4. Just yes, 2 to the negative 4 is 16. 1/16. Okay? And then I can use that latter property and I can bring the negative 4 down. Okay, so let me bring that negative 4 down. So that means I put it in front. Then I have -4 times this. It's the same as x times this. It's the same thing. So what do I get as an answer? Just x equals -4 equals x, right? We go with that? Okay, that's nice. If you just type the original problem in, I don't know if any of you saw that, but did you see it? Did you see what happens when you type the original problem in? It just gives you the answer right there. Uh-oh, it's the wrong answer though. Oh, because, I'm sorry, this is log base 5. Shh. And now I get the right answer. Do you see how it drew a line at -4? So you don't even have to do for this one. For this one, if no matter what the problem is, there's 1/16, 2, that's going to be -4. Okay. So these are just going to give you 3 properties. There's usually a ladder property, the last one, but again, you could just put an X in and have it. You could just ask Desmos to solve for you. In fact, you could do that for all of these. Okay, but please try that. My job is to teach you these properties of logs. So if you encounter them, you'll learn them. Okay. Second one, this is to write as a single logarithm. So this is just a bunch of those properties. They're all log base 5. But if you notice, okay, so I don't think I can copy these, so I just have to put them in here. So it's 3 log base 5 of z plus 2 parentheses log base 5 w minus 5 log base 5 of y. Okay, so I'm just going to do some properties here. Take this, and I'm going to first distribute that 2. I don't like these parentheses. They mess me up. So I'm just going to take this regular multiplication. I don't got to do nothing but put a 2 there, make that -10. And all I did was some algebra. Okay. Is everybody with me on that? I didn't have to do anything except distribute it. I just distributed, so just say algebra. Okay, next thing I'm going to do. We need to combine these logs, but I have these numbers in front. So how can I get rid of the numbers in front? I can use which property? Which is that property that makes it a ladder? 3. So where does this 3 go to get rid of it? Where do I have to put it? Becomes what? C cubed. Very good. And this 2 becomes w squared. And this -10, let's make it plus. I'll put a -10 there. Okay, now I can use property 2. And I can just put them all together as 1 log base 5 of all this stuff. This one. This one. This one. Okay. If I ask Alex to give me the answer, it'll probably put the y in the denominator. It'll probably give me this. And it's the same answer. It's just going to say this divided by y raised to the 10. Okay, they're going to put that down in the denominator. And they might say with all, no, single logarithm. That's fine. And they're going to put parentheses around it. I don't have parentheses around it. See, they put the y to the 10. But it's the same thing. All right. Okay, so you can use those properties, or you can just throw this into Desmos. This is a solve. Just throw it into Desmos. It'll tell you what the answer is. Well, but it might be hard to get. Oh, and then when it's in 2 decimal places, that's fine. Okay, next one. Solving. Here's another one. It's harder. You can use those properties. You can combine them and drop logs. It's fun. Look at the work, or you can just throw it into Desmos. Okay, these problems are really good problems. These are word problems. And since this is a continuous exponential growth model, this means you're going to be solving for an exponent. Very likely, they'll have like 2,300 bacteria becomes 2,600 bacteria, and it took so many hours. You're going to use this formula. You're going to use this one. You're going to use P equals QE raised to the RT. Now you can solve for this. So what I'm saying is you can use Desmos to solve for these. But the hardest part is figuring out what everything is. Okay? And if you ask Alex for explanation, they're going to solve it by hand. Alex's explanation is first they put everything in. There's the formula. And once at that point, I could just right here, I could just put that in Desmos. It'll tell me what R is. But here they divide, and then they take the natural log of both sides, and then they bring that. This is a function of it composed with its inverse, so you get 4R. And then they solve for R, and then they put it in, and they put it in the calculator, get an answer. But honestly, just put it in Desmos, the whole thing. That will be much easier. Graphing calculator to solve. Okay, so now for this one, give me a minute just to show you how to do this one. For this problem, you're going to use Desmos. You have to use Desmos. But you're not using any of the properties. This one is just basically a snub at the properties. If you graph y equals e raised to the x minus 3, and you graph the other side, y equals x minus 1. Okay, what you're doing is basically, you're saying one side of the equation has to equal the other side of the equation. So let me just see who's who. The green one is this one. The blue one is that one. All I need to do is look for the intersections. And those are the two answers, 4.14 and 1.15. And you do it that way. That's an intersection method for solving. You could also just try it the other way. Hold on. I think you might be able to just type the whole thing in and let Alex try it. It'll try to find an answer. Oops. I think. Yeah, so it finds, yeah, it does. It finds the same answer. But when you do it that way, Alex is reluctant to tell you the answer. I'm clicking on these lines and it's not telling me. So you know how you can zoom in if you want, or here's a trick you can use. Change the equals to a minus sign. And Alex will always tell you the zeros, no matter what. So if you just look for the zeros, there's your answers. Okay, so you're creating a new function, just moving everything to one side, finding the zeros. So Alex will tell you the answers. Otherwise, Alex is, I don't know if it's programmed, if Desmos is programmed not to tell you where those lines are, but I can't. I have to zoom in to see what those lines are. But if I put a minus there, the minus there, see, the zeros go right through those points. Okay. And that's what that'll tell me. Okay, that's all of it. So we're doing the same thing. I just want you to get the idea. We're doing the same thing over and over and over again. Evaluate and solve, evaluate and solve. It's just, these properties, these functions have a lot more properties. Okay, there's a lot of log properties. But wait, mod 8 is coming up, and that's the beginning of trig. And mod 8, 9, 10, 11, 12, 13 are all trig. And do you want to talk about a lot of properties? There's a lot of properties in trig function. So this is nothing compared to that. But these are, I think these are probably more useful than a lot of the trig stuff. Okay, but that being said, when I lived in my old neighborhood, and I was trying to do something useful for my neighbors, they were all great. They were like plumbers, electricians, and stuff. They came to my house all the time, helped me out. Twice I was able to help them. It was both trig problems. That was the only way I could contribute to their lives at all. It was from choosing trig. So the next part of the course is probably more interesting, but it's very different from logs and exponents. Okay? All right, I'll have a good week. I will see you next time. Remember, when the practice midterm comes up, don't just take it. Take it like it's a real test, and don't ask me to take them. It's not. It's really for you to take once as a test. It's not like the quiz that like you can't do it, submit it, do it, submit it, take it like a test. Afterwards, we'll talk about if there's anything else you have to do with it, but for now, take it like a test and you only get one shot at it, and it's time, but there's no on or off. Yes, I'm gonna say this, how do you want it? How would you like this? I could put it on chat if you want it. Let me just throw it on chat now in case anybody at home wants it. Otherwise, I'll just put it on. It's on chat, but I'll put it in. I'll put it here. Under where would you like it? Announcements.
Yeah.
Okay, so I'll just put it here. Okay, so it's right in announcements then.
Thank you so much. Thank you.
Days decimals.
Have a good night.
Thanks, you too. Well, I felt a lot better after I threw it on. You too, bye-bye. Good night, David.
Hello?
Yeah.
Yeah, Professor, I just had a question.
Moment, what can I do for you?
I'm sorry, I can't really hear you.
You can't hear me?
Oh, no, I can hear you now. Never mind.
Okay, what's up? What can I help?
Yeah, my question was just like what topics were going to be on the midterm? Like, is it just everything like we did? Like, is it like on all like the quizzes that we did previously?
All of this to what I just finished, quiz 7, all on the midterm. What's not on the midterm is I don't think there's any trig on the midterm. That's what I start next week. So logs, exponents, polynomials, rationals, all of that on the midterm. Okay.
Okay. And is there like a way to study before I take like the practice midterm? Like, is there like something on Alex or?
Yes, the quizzes, all the quizzes. So if you want, not all the quizzes, you want to know all the questions on all the quizzes, do these reviews. There's review test 1 and review midterm, all the quizzes 1 through 8. But 8 is not on the midterm.
Okay.
Okay.
So it's just quizzes 1 through 7, basically.
Let me just make sure. Practice with the content. Do you see any trig on here? No. Nope. There's logs, there's exponents, no trig. All right.
All right.
But that's what you need. 1 through 7, all those quizzes. You could look at anything you missed. It's a good candidate for studying. You should always study things that you miss. Okay, if you haven't done the quizzes, then do those reviews. And again, whichever ones you miss are the ones you need to go back and study. I believe in cramming for a test. Totally 100% cram, but don't cram stupid. Cram the things that you miss. So in other words, make note of them, write them down, put them somewhere in a file, something, and then study those because those are the mistakes you're going to make again. Anything else is not work. Don't go over homework. You don't do every single thing that you've ever done. You just do the ones that you got wrong. Like, for example, tonight I called Tatiana Stephanie. $5, I will bet you that I will call her Stephanie again. Because that's a lot of money. I don't gamble. But I know that I'm going to call her Stephanie again. I made that mistake once. I'm going to make it again. Okay?
Right. Yeah.
Okay,
So, yeah. So, I mean, well, like, because all the older quizzes are locked, so I can just review with the review test 1 and the midterm, right? Like the review midterm.
They're not locked. If you took them, you can look at them. But if you didn't take them, you have to do the reviews.
No, because I did it and it's just saying like closed, like status is closed.
I know, but click on the test itself.
Oh,
The
Click
test.
on the test, like click on quiz 13 or something, and it'll show you. Yes, have you done this, Joseph? You look at that, yeah. I don't have a student view for this, but yes, that's what you do. Well, you can go to Gradebook and click on the test too. Either way, you should be able to see what you missed. Okay,
Okay, yep.
okay. Anything else I can help you with? I'm sure you
No, that'll be it.
can. Stop and share.
All right. Have a nice day.
Thanks. You too, a moment. I just have to stop the. So look, I learned this the hard way. If I want to turn off the stop the. I have to share something first. So I have to share it. And then I'm trying to find out how to stop the whole how do I stop it? The live feed that's going on right now. There's some trick to getting out of it. I was going to be so clever and show you what it is, and I'm screwing it up. It should be here, and it should be live feed.